In this video, I'm going to do a walkthrough of the buffer overflow methodology for the OSCP exam. I'm going to be demonstrating using this buffer overflow prep room on TryHackMe. In particular, we're going to go over buffer overflow 9, this exercise here, because in this one there is a couple of gotchas that might trip you up during the exam if you're not careful. So it's a pretty methodical approach to this. You can pretty much follow the steps and copy exactly what is being done, and you should be able to do it no problem in the exam. So we're going to start off by running the vulnerable application in Immunity Debugger, and we're going to start off by fuzzing this program. So we're going to load up the vulnerable program and hit play in Immunity Debugger. So now that this program is running, go ahead and copy this script over here and we'll put it into a file. So just go ahead and change this to buffer overflow 9 because we'll be doing that in this video, and go ahead and run the fuzzer. And that's going to give us an idea of how many characters we need to send to this program to control the various registers that we're going to need for doing the buffer overflow. So you can see it's crashed at 1,600 bytes. In the next step, we're going to create a cyclic pattern of 1,600 bytes using this metasploit command. So go ahead and copy that, and we'll change this to 1,600. And next, copy this script here. So this is going to be our exploit script that we're going to be developing as we go through the various steps in this exercise. So for this pattern that we created here, just copy that into the payload variable in our exploit script. And we'll change this to buffer overflow 9 as well. And we're going to go ahead and run this again. So before we do that, we have to restart the program because it is in a crash state. So we'll just reload it back and hit play, and then run this exploit script again. So it's done, and now switching back to Immunity Debugger, we can see the program has crashed. Now in Immunity Debugger, we can find the offset by running this command. So go ahead and change this to 1,600, and that should give us some output for us to figure out the offset for this buffer overflow. So we can see here that the EIP register has a pattern at 1,514. So this number here is going to be our offset. So we can go ahead and put in 1,514 here, and we can get rid of this payload for now. And we can now put in AAAA here in this return variable, and just run the script again to make sure that it's actually working. Actually, we'll change this to 4 B's instead, so we can see when the A's stop and then the B's begin. So go ahead and rerun that exploit script. And now if we switch back to Immunity Debugger, we can see that we have overflowed this program with 1,514 A's, and then we have put in 4 B's, which correspond to the number 42, and that's filled up the EIP register. So just doing this has confirmed that we have the correct number of offset of 1,514 here. Next, we have to find the bad characters. So go ahead and copy this into a Python script again. And copy this into our exploit script in the payload variable. So go ahead and restart the program and run the exploit script again. Switching back to Immunity Debugger. Now we can run some commands to generate a byte array and figure out the bad characters in this program. So go ahead and generate the byte array like so. And now we can figure out the bad characters by running this command. So for this address, we have to put in the address of the ESP register. So double click on that, copy this, and we'll put it into this command down here and go ahead and press enter. So now these are the potential bad characters that is in our program. We've got 00, 04, 05, 3E, 3F, E1, and E2. Now, not all of these are going to be bad characters. You can essentially skip every sequential character and assume it's not a bad character for the first run through. So we'll put 00 because that's always a bad character. 04, 05 is right after 04, so we'll skip that one. Put in 3E, 3F is right after that, so we'll skip that one. And then we'll put in E1 as well. Now we'll have to run this again because in case that 05, 3F, or E2 is in fact a bad character and we just skipped it. So to confirm that, we first remove these 4 characters from our exploit script. So that's a 04. Get rid of that. We've got 3E. Get rid of that one. And then E1. Get rid of that one. Okay, so let's go ahead and restart the program and run that again to confirm if we've missed any bad characters. Now we'll update this ESP register value here. And go ahead and rerun that command. So now we can see there is a different set of characters here. So comparing the bad characters that's showing up now, we can see that we've got 0, we've got 04, we've got 3E, and we've got E1. Now the 2 new characters that appeared is 3F and 40. So for these 2, since 40 is just after 3F, we can just put in 3F here. And we will ignore 40 for now. So we'll assume these are the bad characters and rerun the script again to double check. So 3F, we'll remove 3F now from our payload string. And go ahead and restart the program again. Get that updated ESP register value. And let's see what it says now for the number of bad characters. So now we can see that these characters correspond exactly to the characters we've noted down here. So at this point we can stop and say these are all the bad characters in this program. Now if you do see new bad characters appear here, just repeat those steps again until you've got the exact number of characters matching this output here. Now we can go ahead and generate our MSF Venom payload. For this, I actually like to use a Windows bind shell rather than a reverse shell, just so that in the OSCP exam, the examiners don't need to regenerate your shellcode and your script will essentially work out of the box. So go ahead and put in your bad characters in here, 3E, 3F, E1, and go ahead and generate that payload. So using a bind shell rather than a reverse shell is actually something John Hammond mentioned in one of his OSCP prep videos, and I thought it was quite neat. It probably doesn't matter, but you never know, just in case. So go ahead and put that into the payload variable, and we are almost done. So for the final step, we have to find the jump point. So we have to run this command and also just include the bad characters in this command as well. Go ahead and run that command in Immunity Debugger, and we can switch over to the log if that doesn't pop up straight away for you. So you can pretty much use any of these values here. We'll just stick with the first one just for simplicity's sake. So that is 62, 50, 11 AF. So we'll write it in Little Endian format. And put this into our return variable here. As the final thing we have to add to this exploit script, we have to add some padding. So go ahead and add that into our script. And now it should be all good. So we've got our payload set up. So it's going to be opening port 9000 for us to netcat to get our shell. So go ahead and restart this program and we can run this exploit against it. Okay, now if we NC to that machine, we should be able to get a shell. Okay, cool. Yep, so that exploit worked and we got a shell. So for this method, since it's using a bind shell, you can essentially just give this script, put this in your appendix for the OSCP exam, and the examiner will essentially only need to run the script as is without generating shellcode in case of if you are doing a reverse shell, the IPs might change, for example. So this will essentially just cut down the error, the potential error in that. And yeah, hopefully that made sense. I did go over it pretty quickly, but pretty much if you just follow these steps as is, it's pretty simple and you should be fine for the OSCP exam. The 25 points for this is probably the easiest 25 points in the exam. I hope that was helpful for you guys, and leave a comment in the comment section down below if you have any questions. Thanks for watching, and I'll see you next time.